Welcome everybody to this video, and in this video I will try to show you the essentials of the underwater optical wireless communication dealing with the visible portion of the spectrum. In this video in particular I show you how to send signals from LEDs through some photodiodes by using as a medium water. And water is an interesting medium, especially if you want to send signal in airborne, open sea, open water environment. So that is really interesting. So why optical communication is really important for the underwater communication? Let's start from one interesting consideration. The radio frequency word is absolutely not suitable for this kind of communication due to the behavior of the radio frequency signals in the water. On the other hand, a very popular technology is the acoustic signals sent throughout the water. Okay, unfortunately, the propagation speed is really low. We have some reflections and this generates intersignal interference, but essentially the strong limitation comes from the sources, from the emitters, because acoustic modems are transducers and they have to convert an electrical signal into a mechanical one because we want to generate a pressure wave. So the bandwidth is very limited. We are talking about few kilohertz, let's say 10 kilohertz or something more. That's leading to a very low bit error rate. From this point of view, optical wireless communication is more suitable. Unfortunately, with respect to the propagation of sounds in water, we have limited coverage, so we cannot achieve the same distances of the underwater acoustic communication. But at the same time, we are able to speed up our transmission rate, and this is really important. Because if you have some applications, like for example video underwater, okay, with optical wireless communication you can achieve this kind of target, while this is absolutely out of scope for underwater acoustic communication. We must say that from the propagation point of view, when the depth where you are acting your communication is increasing, so you are going in depth in the water, then the behavior of the channel is wavelength selective filter. That's meaning that the first component that is cut is the red one. Then by increasing the depth, you are moving from red to yellow, then green. So at very high depth levels, you have essentially that your main component that is able to pass through in the wavelength domain is the blue one. So then I am going to show you a very simple experiment taking our labs, and in that experiment we have a very short range communication, optical, in the visible portion of the spectrum, so you are able to see how this works, and obviously this is only a simple exercise just to show you what are the potentials of this kind of communication.
Specifically, we consider in this video a very limited propagation scenario in a transparent box filled with water that we suppose, at first, to be really clear. This allows us to look at the performance offered by a multiple input, multiple output system, also known as MIMO, when we use white, blue, green, and red LEDs. At the receiver, we use multiple photodiodes able to detect the light and convert it into an electrical signal. Both transmitter and receiver are controlled by two Arduino Genuino boards, each one controlled by a computer where MATLAB and Simulink run. We aim at transmitting a text, and we use some pilots in order to allow signal synchronization and channel estimation to be used for detection and the receiver side. The transmission is simply overridden in parallel by all the LEDs, and the detection is sufficiently easy when the water is crystal clear. This is because the channel doesn't present attenuation that can induce errors at the receiver. However, we have some reflections from the box sides and the bottom that can generate inter-symbol interference. It is worth highlighting that when the external light is on, this induces interference on the received signal. This effect is not so different from the sunlight penetrating water at reasonable small depth levels. However, if we try to cover the receiver from the lighting around, the amount of light entering the photodiodes is due to the soul transmission. We can see here the experiment that we start with the transmission by red LEDs of some samples, some symbols, in order to send a text from the transmitter side to the receiver one. And you can see here by zooming in on the screen that essentially the text arrives correct. So let's see what happens if we try to transmit an image, a very simple image characterized by black vertical stripes, and here we are using white LEDs. So you see in the screen the symbols that we have received, and since we have some inter-symbol interference generated by the bottom of the box, here unfortunately we have a corrupted image, while the image is received correctly if we put a black paper on the bottom of the box, still by transmitting with white LEDs in the on-off keying modulation, because in this case, as you can see now, the image is received correct, so we have two vertical stripes. So then let's move to another interesting situation when we consider the turbidity of the water. So we can see that we have dirty water moving from clean water to brown water, and it is interesting to see that the brightness of the LED is lower, obviously, by looking with the eye, and also the amount of external lighting is at the photodiode smaller, so we can continue our experiment simply by taking on the ambient lighting. And here we are using green LEDs, but due to the reflections and also the attenuation induced by the dirty water that is a frequency select, is a wavelength selective filter, we have that the image is strongly corrected, as you can see. And then what happens if we use blue LEDs? We have the same problem essentially, because the brown water is acting as a filter, and that is reducing the amount of light entering the photodiode. So the performance, as you can see, the dynamics of the signal is smaller, the performance are poor. This is the reason why we can see this situation of the image that is strongly corrupted. So the errors that we have with the red LEDs is not so bad, in the sense that the brown color is sufficiently close to the red, so the light that is filtered by the water is not so much, even though we have still some few errors of the image, as you can see. But what happens when we use wide LEDs? In this case, the amount of light is higher due to the fact that we are using the whole spectrum, and the performance are sufficiently good. You can also see that the light is brighter with respect to the red, green and blue situations. And this is the reason why we are able to detect the image in a correct way, as you can see here.
So we have seen what we can do with the underwater wireless optical communication, and obviously we can do more and better. And you also have seen the impairments, the issues connected to this kind of transmission technique. So you are invited to apply for a PhD position. We have multiple positions. Usually the first window opens at April, and in that call only students coming from foreign countries can apply. The second call is in July, and it is open to Italian and students coming from all the world. But please feel free to contact me to ask some more information about how to apply, about timing, and about possible research together, not strictly related to PhD position. So, thank you for your attention. Goodbye.